Now let's do some redistribution on R4. It's an ASBR. We are going to run another routing protocol on R4 besides OSPF, and I'm gonna deploy a new router here, R6, and we are going to create an EIGRP autonomous system here. And we are going to inject EIGRP routes into the OSPF domain. And later I'm gonna show you how we can stop these type 5 external LSAs at the ABR, and we are going to make area 2 a stub area. So let's quickly configure EIGRP on R4 and R6. So let's start with R6, and I have already pre-configured this subnet and no-shotted the interfaces, as you can see. So router EIGRP, and this is the AS number, not the process ID, and this has to match with the neighbor router. And I'm just gonna issue one network statement which will include all interfaces. So network 0000 255.255.255.255. This is the 0000/0 address. Again, this is a wildcard mask. This just means /0, so all networks. And I'm gonna create many loopback interfaces here, and each of them will create a type 5 external LSA after redistribution. And let's also configure R4 to establish the EIGRP adjacency. So router EIGRP AS number, and here we need to include this interface G0/1 with the network statement. So network 10.0.46.2, and the EIGRP adjacency has been established. So on R4 we have now two routing protocols running. Oh, let's check the routing table. So we have both EIGRP and OSPF routes, and by default the other OSPF routers here are not aware of this network. So just to prove that, let's ping R6 from R3, for example. So ping its loopback address, and it should time out. What we are going to do is we are going to redistribute the EIGRP routes on the ASBR into the OSPF domain and create so-called type 5 external LSAs, which are for the ASBR is going to flood across all the areas in the OSPF domain. And now I'm gonna start a packet capture on this and on this link. So on R4, the ASBR, we are going to enter the global OSPF configuration mode and distribute EIGRP AS number 100 into OSPF. So this statement should generate type 5 external LSAs. So we have 6 type 5 LSAs, 5 for each loopback address. And 1 for this subnet here, 10.0.46.0. And we also have a type 4 summary LSA. This is generated by the ABR. So type 5s are just basically prefix information, and type 4s contain information how we should be able to reach the type 5 prefixes. So they basically mean that we should use this next hop address, which is the ABR router 2, to get to the external routes. And let's check the routing table of R3, for example. And now we have external route E2, which is external type 2, which is the default, and it always has a cost of 20, which is pretty inaccurate in this case. Type 1 would be much more accurate. I will show that in another video how that works. But now let's test the connectivity and ping R6. And the ping fails. That's because R6 is not aware of this OSPF network. So we could do another redistribution on R4 and redistribute the whole OSPF domain into EIGRP, and it would work, but I'm gonna simply create a default route on R6 and point it to R4. So on R6, IP route 0000/0. That's the default route, and the next hop address is R4's G0/1, which has an IP address of 10.0.46.2. And now we should be able to reach this EIGRP network. So let's try the ping again. And the ping succeeds. Now let's take a look at R3's link state database, show IP OSPF database. And since we have injected external routes, we have both type 5 and type 4 LSAs, one for every prefix, and we have a separate route in the routing table for each prefix as external type 2, which is not really necessary in this case, since the only way to get to the EIGRP domain is through the ABR. R2. So it would be much more simple to replace these routes with a default route pointing towards R3, sorry, R2, the ABR, and we would have less entries in the routing table. And we could get rid of these type 4 and type 5 LSAs. And that is what we are going to do. We are going to make area 2 a stub area on router 2. We are going to say area 2 stub, and the neighbor relationship is broken now because the stub flag doesn't match with the neighbor router. But on R3, we are going to do the same thing. So area to stub, and again we have a neighbor relationship established. So now let's take R3's routing table, and now we only have a default route instead of the external routes, which is a good simplification. And let's see the link state database. So show IP OSPF database. And now we don't have type 5 or type 4 LSAs. And instead of having them, the ABR R2 injects a type 3 default route into area 2. See, this one. And that's what we have seen in the routing table. And of course, we still have connectivity to the EIGRP network. Now let's go one step further. See these type 3 summary LSAs. These are generated by the ABR R2, and these are prefixes for every network within the OSPF domain besides this area, area 2. So within area 2, we have type 1 and type 2 LSAs, and these are used just within the area, and these are not forwarded by the ABR, so only flooded just within the area. And these type 3 summary LSAs contain simply every network prefix for every inter-area routes in the routing table. If we had more routers and more complicated topology, we had maybe hundreds of them, which is not really necessary, since the only way to reach these networks, area 0 and area 1, is through the ABR R2. So we could get rid of these as well, and instead of having many inter-area routes, we could have a single default route pointing towards R2, the area border router. So let's do that. And it's a single command. And we are going to make this stub area totally stub area. So on R2, we are going to issue area 2 stub, no summary. And again, this is a simplification. Besides blocking the type 5 and type 4 LSAs, we are also blocking the type 3 as well at the ABR. And we should have a single type 3 LSA on R3, which should be the default route, or show IP OSPF database, and that is what we have here. It is advertised by the ABR R2, and if we look at the routing table, we don't have inter-area routes anymore, and we only have a single default route. So our LSDB has been simplified, but still we have connectivity to the outside. So let's ping the EIGRP network, and the pings still succeed.